Hello grade 10s and welcome back to another practice video. In this video we're going to be looking at a question from the Gauteng Department of Education's provincial exam that was written in June 2019. This question says, consider the circuit below. When the switch is open and the voltmeter is connected across the battery, it reads the EMF of the battery. As you can see over here, the switch is open. Now they say when the switch is closed, so this is a different situation, the ammeter A1, which is over here, has a reading of 5 amperes, while the ammeter A2, which is measured or which is connected over here, has a reading of 3 amperes. Okay, so that's the information that's provided to us, and we're dealing with two situations, one where the switch is open and the other where the switch is closed. This circuit, as you can clearly see, is a parallel circuit. Now, the way that it is drawn can be a bit confusing to some of you, so I'm going to redraw the circuit on the right-hand side. You are more than welcome to redraw the circuit so that it makes better sense to you. Just make sure that you draw it correctly. So it's good practice to go and practice a few circuits. Perhaps show them to your teacher so that your teacher can tell you if you're on the right track or not. But on the right-hand side, we have an equivalent circuit. Now, question 6.1.1 says, define the term EMF of a battery. We say that the EMF is the potential difference measured across the terminals of the battery when no current is flowing through the circuit. The fact that there is no current flowing through the circuit is very important to mention. Remember, the EMF is the maximum amount of potential difference that the battery has to offer, but it does go down, or it does become less when connected in a closed circuit, because we know now that batteries contain internal resistance. For writing this down, you're going to obtain 2 marks. On to question 6.1.2, it says calculate the effective resistance of the combination of the 2 resistors. We have the 6 ohm resistor and the 4 ohm resistor, and we would like to find out the effective resistance. We're going to answer 6.1.2 at the top over here, and we say 1 over Rp is equal to 1 over R1 plus 1 over R2. It's very important that you write down this formula, because for it you can obtain a mark. That is 1 over 6 plus 1 over 4 is equal to 1 over Rp. So we have not obtained the total potential difference yet. We only have, or the effective potential difference, we only have 1 over Rp. And when we plug this into our calculators, we find that 1 over Rp is equal to, in fraction form, 5 over 12. Now, to obtain the effective resistance, we find the reciprocal, so that is 12 over 5, and we find that 12 over 5 in decimal form is equal to 2,4 ohms. So the effective resistance is 2,4 ohms, and as expected, the effective resistance is smaller than the size or the resistance of the smallest resistor connected in this parallel circuit. Remember, in parallel, the more resistors you add, the lower the effective resistance is going to be. For this, you're going to get 1 mark for writing down the formula, 1 mark for your substitution, and 1 mark for your final answer in decimal form, provided that you have the correct SI unit. On to question 6.1.3. It says, what will the reading on ammeter A3 be when the switch is closed? Now, the switch is closed, right? So that means charge is able to flow. When current is able to flow through the circuit, they say A1 has a measurement of 5 amperes and A2 has a measurement of 3 amperes. This part of the circuit is called the main part of the circuit. It is equivalent to this section over here of my drawing on the right-hand side. And we now know that the main circuit measures the total current. So what that means, grade 10s, is that A1 is giving us the total current. Then what happens is that the current divides. So this is the positive terminal. The current is going to split up. Some of it will go this way, and the rest of it will go that way. Or in the case on the right-hand side, some will go this way, and some will go that way through A3 and A2. We've been provided with the reading on A2. It is 3 amperes. So of the 5 amperes, we see that 3 amperes is going through the 4 ohm resistor. We know that the rest is going to go through the 6 ohm resistor, through A3. Therefore, to answer question 6.1.3, we're simply going to say that the current through ammeter 3 is equal to the total current through ammeter 1 minus the current through ammeter 2. That is 5 minus 3, which gives us 2 amperes. We're going to obtain 1 mark, or perhaps 2 marks over here, for showing the calculation, and 1 mark for the final answer. A question like this will normally be out of only 2 marks, but we're going to divide or split up the marks as I have over there. Now, what is interesting to take note of is the fact that A3, which is measuring the current through the 6 ohm resistor, has a reading of 2 amperes, while that is going through the 4 ohm resistor is 3 amperes. As you can clearly see, the smaller resistor has more current flowing through it because the smaller resistor resists less current, and therefore it allows more charges to pass through it per unit of time. Let's move on to the next part of this question. This part deals with a series circuit, and I say that it is a series circuit because we can see that all 3 of the resistors here are connected one next to the other, and that means that the current flowing through each one is exactly the same. The information provided to us says, consider the circuit below. When the switch is closed, voltmeter V1 over here reads 4 volts. That means, and we can already write that down, that the total potential difference is 4 volts. Then it says V2 reads 1,6 volts. That is given to us over here on this side. And lastly, it says that V4 measures 1 volt. So here is V4 across the 5 ohm resistor, and it is measuring 1 volt. It's very often happens that learners confuse the voltmeters to a parallel circuit, but this is still a series circuit because current does not flow through the voltmeters. It's simply going to flow around this way, and no current is going to go through the voltmeters at all. So this is a series circuit. Question 6.2.1 says, calculate the effective resistance of the combination of the 3 resistors. Now, it's a lot easier to perform this calculation for a series circuit. We simply say RS or RT is equal to R1 plus R2 plus R3. And it's good practice to always start off by writing down the formula with subscript so that your teacher knows where you're getting your values from. So that is 5 ohms plus 7 ohms plus 8 ohms. When we total this, we end up with a value of 20 ohms. For performing this calculation, you're going to get 1 mark for your formula, 1 for substitution, and 1 mark for your final answer with the correct SI units. On to 6.2.2, it says determine the voltmeter reading on V3, where V3 is this voltmeter connected across the 7 ohm resistor at the center. We remember that this is a series circuit. In my previous videos, I said that this is the mother, the mom, who is splitting up the food or dividing the food between her 3 children. Okay, so some will go here, and lastly, some will go over there. As you can see from the 4 volts, we have 1 volt going here and 1,6 volts going to the right-hand side. So the leftover will go to the 7 ohm resistor. We can therefore simply say for 6.2.2 that the potential difference cross or measured by V3 is equal to Vt minus V4 minus V2. Vt can also be described as V1. So that's going to be 4 minus 1 minus 1,6. And when we plug this into our calculators, we obtain a final answer of 1,4 volts. So this 7 ohm resistor has measured across it a potential difference of, we're going to write that down, 1,4 volts. And you can clearly see over here the relationship that I described in the previous video, that this is divided such that the largest resistor has the biggest potential difference across it, while the smallest resistor has the smallest potential difference measured across it. And of course, that one that is in between has an in-between potential difference measured across it. The bigger child needs to eat more food while the baby gets less food. Okay, so that is your answer to 6.2.2. 1 mark for your workings, 1 mark for your final answer with the correct SI unit. Let's go on to 6.2.3. It says if the current passing through the 8 ohm resistor is 0,2 amperes, what will the current through the 5 ohm resistor be? So the 8 ohm resistor is over here. They are telling us that for this specific circuit, or for this 8 ohm resistor, there is current flowing through it of 0,2 amperes. But we know that this is a series circuit, and in series, current is constant. So therefore, the current that is flowing through the 5 ohm resistor is also going to equal to 0,2 amperes. And the reason we can say so is because current is constant in series. For giving your answer as 0,2 amperes and for providing a reason, you're going to obtain the 2 marks that is indicated on the right hand side. Let's move on to question 6.3. It says, a charge of 48 coulombs flows through the circuit in 2 minutes. Calculate the current flowing through the circuit. This is of course assuming that the current, or that we cannot assume that the current is 0,2 amperes like was given in question 6.2.3. So there's been a change over here. To calculate current, we can say current is equal to Q divided by time. The charge is 48 coulomb. So we're going to say 48 divided by the time, which is 2 minutes. But remember, time is measured in seconds. So we're going to say T is equal to 2 times 60, which gives us 120 seconds. We must first do the conversion. Then into our formula, we plug in 120. If you plug in 2, then you've lost your 2 marks for substitution and the final answer. When we plug this into our calculators, we obtain a final answer of 0,4 amperes. You're going to get 1 mark for your formula, 1 for your substitution, and of course, 1 mark for your final answer. This brings us to the end of this video.